Hello, Joe Reinhardt here again, doing a follow-up video to my earlier one on the Cisco UCS system architecture. I did that one in a whiteboarding session. Wanted to do another version just in a PowerPoint, which you see before you now. We'll go over PC architecture, data center architecture, and then finally UCS architecture. Now, any discussion about server architecture has to begin with the way the actual PC is constructed, how its pieces fit together and how it operates. That actually begins with the CPU, or central processing unit. This is essentially the central brain of the system. It does all the execution of instructions and all of the calculations. But it doesn't do this alone. It relies on memory, short-term storage and working memory for assistance in various tasks. For longer-term retention, some sort of storage media is utilized. It's typically a hard disk drive or something similar. And then finally, there are adapter cards that are installed in the system that allow it to communicate with the outside world. Usually this includes video, some type of serial connectivity, and then finally network connectivity as well. Now, Moore's law states that computing power roughly doubles about every 2 years, and that's certainly the case in this entire system that you see before you. Hard disk drives now are available in solid state. They are larger, faster, and more efficient than ever. Memory has come in a variety of form factors, speeds, and capacities. And then finally, various types of adapters are now available. The CPU itself actually has experienced a great deal of upgrade. It has a great deal more processing power, speed, and capability to execute multiple instructions. In fact, various sockets on a motherboard, there can be upwards of 1 to 2 to several, can actually contain several other processors within each socket. So again, aggregating a great deal of computing power. Now, it used to be that when a server was deployed, it was a single-use type of device. For instance, the examples that are given here. An email server did just email, web did just web, and DNS, just as another example, did just that. One of the things that's happened, though, is the advent of rack mount servers. The idea to be able to get more within a smaller amount of space. And these are designed to be able to do that. Blade servers are another much more popular version, which allows for blades to actually be representative of servers, and then there be even more density in the space. And this has created obviously lots of challenges with power, heating, and cooling. Now enter into that virtualization, this idea of being able to take virtual instances of a server and actually place them on one physical device. And virtualization, you have VMware, Hyper-V, which is Microsoft's version of the same, Citrix, and then Xen working with Linux. The idea is to be able to take the multiple servers and combine them into one. Email, web, and DNS can all exist on one physical box with 3 virtual instances. This entire environment has created even more complexity. When you think about the advances in technology and on the server side itself, and then couple it with a lot of other things like virtualization, it can make things very complex. Certainly there's a lot of complexity in management about this as well. And that's where this particular role within the data center becomes very important. And just looking at the architecture of the data center, we'll start just for grins with a blade server. Now, all sorts of different applications may be running on this, but if there's no connectivity to the outside world, it really can't accomplish anything. So inevitably, you have to have some sort of network connectivity, usually from a network interface card. It can be gigabit, 10 gig, or any other variety thereof. This then connects to upstream switches, and then to communicate with the larger world, are usually a router which can connect to both to the internet and then a wide area network if there are multiple sites. And then finally, there are internal users of the system. And this allows a very robust access between user, servers, and then the larger world. In order to be able to accommodate greater amounts of storage, storage area networking has been introduced. This actually can take a variety of approaches. There are IP-based storage, iSCSI, network-attached storage, and so forth and so on. But fiber channel is actually quite popular. And this uses a completely different type of adapter called an HBA, or host bus adapter. This connects to a different set of switches altogether, fiber channel switches, which operate differently than traditional LAN switches, which then can hook up to the storage area network. So now the blade server has not only connectivity to users in the outside world, but also longer-term storage. Another aspect of this type of an environment in a data center is management. Often out-of-band management is deployed in order to be able to supervise all the different functions working together within the data center. And then, of course, there's usually some sort of management console to manage the blade server architecture. Usually it's a piece of software or some type of a specialized server or workstation. Virtualization requires yet another set of management, usually vCenter or something, vCenter specifically for VMware. And then there are lots of IP addresses that may be involved, some on the physical blade server itself, some for the blades, other parts just for the individual virtual machines. You can see it becomes very complex very quickly. There's a lot to coordinate. And then there's the human aspect. If, for instance, one of these blades needed to be provisioned with a new server or set of servers, there's a variety of individuals that have to be involved. Obviously, the server administrator that oversees everything. But in order to be able to have that go across the wire into the network, there has to be involvement with the network administrator, usually a separate individual, sometimes separate departments. And then if long-term storage is necessary in the SAN, then the SAN administrator has to be involved. There can be a lot of coordination just to be able to get something seemingly so very simple done. And it is into this environment, this type of complexity, that the Cisco UCS comes and actually takes away some of that complexity. So we'll replace the blade server with a Cisco 5108 chassis. This is actually part of the B series, B for blade, that actually, the blades actually fit inside this enclosure. You can have 4 full-width blades or 8 half-width blades. And in addition, there are specialized switches called fabric interconnects, 6120 that has 20 ports and 6140 that has 40 ports, that actually create the connectivity. The fabric interconnects in the UCS actually operate as one system. And Cisco, because of their extensive involvement and development of network infrastructures, is actually able to take these technologies and actually work them together in a way that's pretty impressive. It's standardized on 10 gigabit Ethernet, and that is the connectivity that's used to the upstream switching environment. One of the first innovations that's usually talked about in Cisco UCS is unified fabric, or the idea of a single network infrastructure rather than separate infrastructures, as is illustrated here. In this particular case, I like to call this one ring to rule them all, but you can actually see that this complexity in the fiber channel environment can go away. In fact, the storage area network can actually directly connect via fiber channel to adapters within the 6120 and 6140s. So all the intervening devices don't have to be there anymore. In addition, there's integrated out-of-band management as part of the system, so this separate management network also does not have to be there. This creates a great deal of simplicity in terms of this idea of a single network fabric in order to be able to handle SAN, fiber channel, local area network, and management functions. In addition to the unified fabric, there's also the UCS Manager, a single pane of glass for all management functions related to servers and the data center. The UCS Manager is actually embedded in the 6120 and 6140s, and it allows for the physical management of all these resources as well as the logical management. In fact, Virtual Center actually has a direct connection into the UCS Manager, which is a GUI-based system. It's very intuitive, and any changes that are made within UCS managers can actually be propagated and bidirectionally pushed back to Virtual Center. So this allows for a single pane of glass, a single point of management for all of this. Then finally, not finally, but there's service profiles, which is this idea of abstracting the personality or the distinct elements of the server from the physical hardware itself. So the blades don't have intelligence in and of themselves. They actually have a service profile built that's pushed to them at runtime. If, for instance, you wanted to make a change on one of the blades, you can vMotion all the virtual servers off, completely reprovision it with a brand new service profile, and then move it back into the system and bring it back up. All done virtually with a very short period of time. In fact, server deployment on this is rapid versus a little more intensive as in other situations. And now finally, the whole idea of role-based access. Each person that has access to the system has a specific role within the UCS system. Storage administrators will only be able to aspect the storage aspects. Now, granted, it may be dealing with things in the server infrastructure, but it's only the storage elements of that. The network administrator will have access to the network pieces within this larger environment. And then finally, the server administrator can have access to where they need to. This protects, essentially does turf protection for each different individual and each different organization, but in a way that actually helps all of this to work together. So just to go back over the innovations, is there's the unified fabric, one network connectivity for everything, UCS manager, one management point and single pane of glass, service profiles, and role-based access. And all these create compelling simplification and business value within the data center.